Once again from my side, good morning and good afternoon, wherever you are, and welcome to our webinar today. My name is Susanne Kollmeier, and I will guide you through this webinar. Our topic is, are the heavy-duty pumps above and below the ground to optimize your mining operations. My colleague, Magali Levray, she's living in France, will explain how you can reduce operating costs and how to improve efficiency in handling abrasive materials. One additional note from my side, so if you have questions or comments, please use the Q&A chat for your questions. We will collect them, and at an appropriate point during the presentation, we will answer it. Okay, I wish you an interesting lecture now, and I would like to pass the word now to Magali. So it's your stage now, Magali.
Okay, thank you, Suzanne. So welcome to this webinar on SEEPEX application in mining. And indeed, we're going to see today application underground and as well in the processing plants and all other satellite application. So let's start by reminding what is the progressive cavity pump principle. So it is really important to understand that PCP transfer fluids by means of the progress of a sequence of fixed shape and sealed cavities. In blue here, we see the fluids being displaced, and we understand with this functioning principle that this is how we can handle shear sensitive, fragile, and abrasive slurries, because the abrasive particle or the fragile particle remain sealed in their cavities as the cavity progresses along the rotor. So with that functioning principle, we really understand why this is a perfect technology to handle abrasive and shear sensitive fluid. Important as well to understand that the lubrication between the rotor and the stator is ensured by controlling the sliding seal between cavities. And each seal has only to deal with the pressure difference between adjacent cavities. So as a result, for low pressure application, we have one stage pump that can handle a maximum discharge pressure of 6 bars, that is 90 psi. And for higher pressure application, we're gonna add stages so that we can handle the higher pressure. So up to 16 stages, that is for a discharge pressure of 96 bar or 1400 psi. Why use progressive cavity pumps? There are two reasons that we can distinguish. One is process reliability, and the other one is to decrease the total cost of ownership. So as far as process reliability is concerned, we've seen with the functioning principle that the technology is ideal to handle shear sensitive and abrasive fluids. And by just adjusting the material of construction, we can, of course, also handle corrosive fluids. So even when we have a combination of shear sensitive, abrasive, and corrosive fluid, the progressive cavity pump remains an ideal solution to handle this fluid. There are positive displacement pumps, which means we have a constant flow regardless of variations likely to occur in operating conditions. Whether we have variation in the dosing of the flocculant that will influence on the percentage of solid we will recover further down in the process, we will have variation in many processes in the mining industry. It is not an issue for progressive cavity pumps. We just need to adjust the speed, and we have no issue with any variation. Also, interesting feature is the high pressure capabilities. We're going to see in this presentation various applications where we have abrasive fluid with high pressure condition, high solid content capabilities with minimal wear. Also, we have non-pulsating flow rate, which is convenient because that means no hammering on piping, no need for pulsation dampeners, and for the process, no disturbances on sensors. Also, for the process reliability, we can count on the great dosing accuracy and very good repeatability of progressive cavity pumps, so we can control our entire process. For the total cost of ownership, SEEPEX progressive cavity pumps offer low life cycle cost because we have a real focus on maintenance features. Our pumps are MIP pumps, that is maintenance in place features. So we have various patented features. We'll see them further down. SCT, that is for smart conveying technology. We're going to see in detail what this is. And we have other features, rotor joint access or drive joint access. These are features that allow us an independent access to each wearing part. Again, making sure that maintenance can be carried out easily and fast. Indeed, because we have no pulsation, as I said earlier, no pulsation dampeners are required, which is convenient, especially when we're dealing with abrasive slurries. And PCPs also have a really rugged design, totally adapted to tough environment and the operating conditions typical of mining and quarrying. If we look at the flow rates and pressure capabilities, here I think it is good to remember what is our maximum flow rate. When it comes to mining, I believe our limitation is really on the flow rate itself. So our maximum flow rate with our biggest pump is 350 cubic meter per hour, which is 1,540 US GPM. Our maximum pressure is 96 bars, 1,400 PSI. So with this pressure, we really cover most of the application we're going to meet in the mining industry. But our real limitation is really the flow rate. So please remember this maximum flow rate and know that everything that is below 350 cubic meter per hour or below 1,500 US GPM, we can use a progressive cavity pump, bringing reliability and decreased cost. Temperature is up to 220 degrees Celsius, that's 428 Fahrenheit. Viscosity, we can reach up to 1 million centipoise. Large particles can go through. We have good suction lift up to 9 meters, that's about 30 feet. We have low NPSH required, reversible flow. In case of clogging, for example, we can reverse the flow. The recommended accessories with progressive cavity pumps are dry running prevention system to protect the elastomeric stator and contact pressure gauge. But one of the first applications we are really known for in the mining industry is about flocculant, and that is because progressive cavity pumps are acknowledged widely as a low shear pumping technology. So we're gonna work a lot with EPCM, providing flocculant preparation plans to the mining industry. So we will have dosing pump, transfer pump, injection pump to dose the flocculant in the thickeners after it's been prepared. And here we are dealing with medium viscosity and light abrasion, especially when we have diluted flocculant and when we use rainwater, which can have some abrasive particle. But generally, this is a viscous application more than it is abrasive. So it's very important to respect the texture of the flocculant. We need to dose the flocculant without breaking the molecular chain of the polymer so that it is efficient and so that we maximize the settling rates in the thickeners and recover the precious metals. So one feature that is often used on flocculant pump is smart conveying technology. And we're gonna see here what smart conveying technology means. So the first thing we see here with this graph is that we can observe our flow rate, and we can see that through time, as it wears out, we have a drop in our flow rate. So normally that would mean we need to stop the pump and change the stator to recover our original flow rate. However, with smart conveying technology, we don't have to change immediately the stator. You can see those 8 bolts outlined on the picture on the right-hand side, and we're gonna give each of those 8 bolts 1/8 of a turn. So this is very quick. It only requires a couple of minutes, and this allows us to retighten the stator on the rotor, and there we will recover our original flow rate. So no need to disconnect the pump, no need to change the stator immediately. We can just retighten those 8 bolts, and we provide longer service life, and this way we can really reduce maintenance times and cost. So we can retighten twice before we actually have to change the stator. And as part of SCT, we're gonna see on the next slide how we actually perform the maintenance when we eventually have to change the stator. So as you can see on this video, we gonna remove those 8 bolts and we can access the split stator. So that split stator enables us to remove the elastomeric stator, which is in 2 parts, and gives us also direct access to the rotor without the need to disconnect suction or discharge piping. So once again, maintenance in place, no need to disconnect the suction of discharge piping. We can first readjust the stator, and eventually we can replace the stator, and that is an operation that only requires about 15 minutes. Other application famous with progressive cavity pump is for flotation circuits. So we're gonna have a lot of pump again here for the reagent preparation plant, preparing the reagents, and we will have pumps transferring, injecting those reagents wherever they are needed. So for small flow rate, we have the MD series, which has a maximum flow rate of 1 cubic meter per hour, that is 264 US gallon per hour, and maximum discharge pressure 24 bar, that's 360 PSI. So here again, those reagents, they can be expensive chemicals, So we don't want to waste them. We don't want to waste a drop. And also because these processes are sensitive, this is where we recover the precious metal. So we do not want to overdose or underdose, which could be detrimental to the recovery rates. So using progressive cavity pump, because we have product integrity, no pulsation, that allows us to have great dosing accuracy, great repeatability, no pulsation. So indeed, whatever the discharge pressure, we will have a constant dosing flow rate. So very often I can see peristaltic as well used on this application, but just above 3 to 4 bar, then the dosing accuracy isn't that great. Whereas with progressive cavity pump, the dosing accuracy will remain perfect even with pressure variation. Another application we have in mining industry is with oily waters, and that is coming from wash base, for example, where we're gonna have to separate the oil from the water. So for oily water separation, we often provide even wall stator. And the reason is with the even wall stator, we have a technology that brings us even lower shear. So we have low internal velocity, and that enables us to recover larger oil droplets and indeed better oil recovery rates. So this is a technology that is used because we have really low shear, but other advantage of the even wall stator is that it enables us to double the pressure capabilities of the pump. So normally a two-stage pump with a conventional stator would reach 12 bar, that's 175 PSI. But a two-stage pump equipped with an even wall stator will reach double this pressure, that is to say 24 bar or 350 PSI. There we have a high pressure pump with a compact footprint. We have reduced length and reduced weight, and this is very convenient when, for example, we have to install pumps on trucks, which is the case, for example, with explosive emulsions. We have a few pumps that will prepare the emulsion and inject the emulsion in the blast hole. So we have space constraint, and with the even wall stator, we are able to greatly reduce the length and the weight of our pumps. So that means advantage in terms of dimension, of weight. It makes the maintenance operation easier for operators because the stator and the rotor are only half the size and weight. And that also means cost savings because indeed less materials are used. So that means spare part cost and maintenance costs are decreased. Even wall stators with their constant thickness also bring advantages and longer service life because we have reduced internal leakage, no risk of swelling because we have that even thickness of elastomer. And when we have high temperature, we have better heat dissipation, again, because of that even wall thickness, which translates into longer service life. After shear sensitive and viscous fluid, we can see here a few examples of abrasive fluids that we typically transfer in mining and quarrying. You see here some examples from clay mud that we transfer from sand washing plants, dewatered tailings, or sludge dewatered after using a centrifuge. So you can see here and appreciate the total solid content up to 65 to 80% on dewatered tailing. So this gives an idea of the capabilities of progressive cavity pumps with thick slurries. When we look at underground applications, so we know here we have heavy duty conditions. The applications that are most famous with progressive cavity pump in underground application involve abrasion and high pressure and corrosion in case of mine dewatering. So one first application is a lot with shotcrete. So that means we need to spray the shotcrete with high pressure so that we are sure it will stick to the walls. So we need high pressure and we need a pump capable of transferring abrasive fluid. We are here dealing with bentonite, cement slurry, grout. So this is very abrasive and we have high pressure. When we are looking at mine dewatering, these are the two pictures in the middle and on the right-hand side. Here again, we are deep underground. So we're gonna have high pressure condition. We're gonna have acidic water coming from seepage water. We're gonna have abrasion from the processed water. So again, when we have these three conditions, abrasion, corrosion, and high pressure, using a progressive cavity pump is an ideal choice. Here you see that these mine dewatering pumps, they're installed in Chile. They're working at 42 bar, and we have 6 pumps installed at different level, 2 at the deepest level, 2 at intermediate level, and 2 others at the most shallow level in the mine. Another application where we use SEEPEX pumps in mining industry is for lime milk. Again, here the application involves the transfer of high solid content fluid. And here again, I will insist that our limitation is our maximum flow rate of 1540 US GPM or 350 cubic meter. We do not require any seal water. You see some the pictures on the right-hand side. These are processed water as a centrifugal pump that are often used on this application, require seal water. SEEPEX pumps do not require seal water. So all those additional costs of water sump, water consumption, water pump to bring the seal water to a centrifugal pump are eliminated when using a progressive cavity pump. Here is a typical example of what we do in mining industry for our customers. Here we are under the thickener. So this is a tailing thickener on gold tailings. And our customer here was using initially centrifugal pump that were failing every week, that really needed the maintenance team to be mobilized around the centrifugal pump every week. They switched to a piston pump, but after 6 months, they also had to invest a huge sum of money to repair the piston pump. And that is when they turned to SEEPEX, and we provided the BN 240-12. You see the pump, the picture in the middle. We are directly under the thickener. And that pump has been working for actually over 20 months without replacing any wearing part, not one rotor, not one stator. So that changed drastically the life of the mine there, where indeed they had really a pump that brought reliability and also great cost savings, as we replaced 45 kilowatt, that's about 60 HP, by a 17 kilowatt drive only, that is 22 horsepower. So that means really here a good example of how we bring reliability and drastically decrease cost at the same time. You can see here the condition. We were working at relatively low pressure, 60 psi, only 4 bars, but solid content 55%, density 2.8, and service life that went over 20 months for all wearing parts. So that is really a typical example of what we can do for our customers in mining. So coming back on SEEPEX pumps advantages, we can really operate even with variation in the process. And as I said, we know there will be variation in viscosity, in pressure, in the percentage of solid present in the fluid. That will not be an issue with progressive cavity pumps. We have no best efficiency point. We only need to adjust the speed to recover the flow rate we require. High pressure capabilities, SEEPEX pumps maximum pressure 96 bars, 1400 psi. That is especially convenient when we're dealing with mine dewatering application, where we can supply just a few pumps to do the job, whatever even when we have high discharge pressure, and still bring a reliable solution on this sensitive application. They're easy to operate, just adjust the speed, no gland water needed, no vapor lock, no pulsation. So cost savings. We see operating speed with product like grout, mortar that we can have in construction, in building industry, drilling muds. Drilling muds is also a very popular application for progressive cavity pumps, also using smart conveying technology on the recycling of drilling mud, for example. And mine dewatering application, we're gonna run at low speed, and this low speed translates in energy savings, translates in no need of seal water, and all these decrease costs tremendously for our end users. So no pulsation dampeners needed, and long service life of wearing parts. Last but not least, easy maintenance. We make sure at SEEPEX we have this extra focus on maintenance feature, bringing features so that we have maintenance in place carried out on our pumps, and independent access to each wearing part. Here we see a few more examples where we are here dealing with very abrasive fluid. We are here on thickener underflow from the concentrate. So here are a few examples with copper. So very abrasive fluid. Here we see we can have SEEPEX pump directly under the thickener. You see on the picture on the right-hand side, this is a SEEPEX pump with the SCT technology. So it is very convenient indeed to have SCT technology when we have challenging fluid with high pressure, with high abrasion. The SCT technology really allows to have good availability of the equipment and to minimize downtimes to a maximum. On other application, we see here when we move to a leaching process, we're going to have precipitates or leach slurry, and we can have application where we're going to have to transfer for filter press. So that means we're going to have abrasion, corrosion coming from the chemicals used in leaching process, whether it's sulfuric acid, whether it is cyanide. But we really have that combo of abrasion, corrosion, and high pressure. So here again, ideal choice is to use progressive cavity pumps for this application. So here are a few examples of cobalt sulfate electrolyte with the precipitate, so corrosive and abrasive, and gypsum slurry transfer, where again here we have abrasive particle. Also very handy for controlling the recovery rate in all concentration processes like we have in carbon in leach process, where it is extremely important to transfer the right solid percentage to the carbon in leach process to make sure we will have the right recovery rate. So using progressive cavity pump, we know we can transfer the right solid percentage to this process, making sure the process are efficient. Here are a few more examples of application on the leaching process when we move to solvent extraction or electrowinning applications. So we see here a few examples of ferric chloride dosing, strip solution, lean eluate pump. So here we're dealing more with corrosion and high temperature. Here on cobalt sulfate filter feed pump, again, we have some leach residue. So again, example where we have abrasion and corrosion. So here what we need is to take advantage of the functioning principle of the progressive cavity pump and just select the right material of construction. So there's a wide range of material available, whether we use cast iron, whether we use stainless steel, duplex, or whether we need to implement some coatings. We have a wide selection of materials available to make sure we can handle all those corrosive fluids as well. Another application that is increasingly popular at the moment is regarding tailings. So we've seen an example on gold tailings where we replaced the piston pump and centrifugal pump by a standard BN pump. And that was on thickened tailings. But as we look at filtered tailings and paste tailings, here we see that at the moment there is an increasing trend on dewatering tailings. So we recover the tailings either from a centrifuge or from belt press or filter press. And instead of using conveyor belts, we are today offering progressive cavity pumps. And for this to recover from filter press or from centrifuge, we're going to use the T series. So the T series is progressive cavity pump, but with a hopper, so that the dewatered tailings falling from the centrifuge or recovered from the filter press, those tailings will drop directly into the hopper. And then we can further pump those dewatered tailings to the tailing storage facility. So conveying capacity with the T series is up to 120 cubic meter per hour. That is 530 US GPM, and the pressure with the T-series is up to 36 bar, that is 525 PSI. If we have a look here just at a few details, you can see that we actually have many different construction for our T-series, so different option available depending of the fluids behavior, whether they're sticky, whether they have a tendency to bridge, depending of the total solid content. We will adapt the material. So here, for example, you can see we have different feeding screw, whether it's an open screw that we will use indeed when we have dewatered tailings that could bridge. So we have different construction available. The common feature, however, is to always have some easy maintenance features. So that's what you will see on the left-hand side, this compression casing. It is a sliding compression casing. Again, the idea here is to facilitate maintenance, make sure that the maintenance can be done with independent access to each wearing part and with minimal downtime and minimal efforts. So really the T-series used for high solid content slurry transfer with minimal wear. Last but not least, for paste tailings, so paste tailings, we've seen dewatered tailings are recovered from belt press or filter press. Paste tailings are produced in deep cone thickeners. And deep cone thickeners will produce this paste, which is a dense phase fluid. And whenever we have this dense phase fluid, we can actually use SEEPEX SAI, SEEPEX Smart Air Injection. So what is Smart Air Injection? It is combining SEEPEX progressive cavity pumps with pneumatic conveying. So you can see on the picture on the right-hand side, you recognize the T-series. We've just seen the T-series being used for dewatered tailings. But here next to the T-series, you can see that we have air supply, and we also have a small SEEPEX MD series that is dosing flocculant dosing polymer on the internal diameter of the discharge pipe. So the conveying capacity, maximum conveying capacity today is 160 cubic meter per hour. That is 700 US GPM. So indeed, we are here looking at paste tailing that normally means high pressure pump, and because we are here using smart air injection, you can see that we have the smart conveying technology logo on this slide, which means that we actually can transfer paste tailing with a low pressure pump. So traditionally, we will see the industry using high pressure piston pump that require a lot of energy. But here with smart air injection, we can actually transfer paste tailings with low pressure condition. So we're gonna see in a moment how it works, but basically what it's gonna do is, because we can bring low pressure condition to this application, we're gonna drastically decrease capex. We only need a low pressure pump instead of high pressure pump. That means, of course, that our OPEX will be significantly decreased as well, because all wearing parts will be under significantly less stress. Low pressure conditions means that our wearing parts will wear off not so rapidly. Because we are using a low pressure pump, that also means that we eliminate the high pressure rated stainless steel pipings, and we can actually work with PN10 flexible piping. So that also really drastically decrease the total cost of the installation. Also included in the system, because we are using air injected in the discharge pipe, that brings us a ready solution to clean the discharge pipe, and thereby avoiding any issues from clogging, whether the tailings got dry in the discharge line or whether it froze and broke the discharge line. Last but not least, SEEPEX Smart Air Injection Controller provides thorough visualization and monitoring of the process, so very easily to integrate into any SCADA system. So we see here on the picture the T-series with the air compressor and the small dosing pump injecting the polymer on the discharge pipe. And we see here the paste tailing. So we see this is the consistency that we require so that we can use smart air injection. And then we see how we came to smart air injection. So normally when we have high pressure condition, we would require a big pump with many stages to work against the high discharge pressure. So this is the conventional solution. But with smart air injection, you can see that we are using a T-series, but the stator is greatly reduced. It is just a one-stage stator. So that means below 6 bars to handle paste tailing. So whenever we're going to reach a given set pressure, we will have an injection of compressed air, and this compressed air will push the dense phase paste tailings that is inside the discharge pipe. And thereby we can push those plugs very easily, just using air injection only 1% of the time, so very low cost on air injection. So this is how we have a low friction loss. We can use a small pump. We're gonna therefore only have very low energy consumption, and we can use low pressure rated piping. So that means low capex, low rated pressure pump. That means low operating cost on energy and maintenance. We normally observe 60 to 80% of reduction, whether on energy or on maintenance cost compared with piston pumps, for example. We have a low total investment. We have reduced pipe and fitting costs due to low pressure stability. We can use indeed PN16 instead of PN120. We can use flexible piping that is also efficient even when we have vertical transport. We can do long transport distances. So we have a lot of system installed in different industry where we work with distance up to 1 kilometer, but we can push it up to a few kilometers. Low downtime due to maintenance in place and increased pump life. We've seen that with SCT technology, whenever the flow rate decreases, the first maintenance operation is actually to retighten the stator, which we can do a first time, a second time before we really have to change the stator. So because we have low pressure feature, we can use SCT and benefit from all the advantages of SCT technology in an application that normally requires high pressure pumps and involves the cost of high pressure condition. It's a totally enclosed system, so no spillage. That is also good because when we're dealing with tailings, we know we have some chemicals that can remain in the tailings, and low downtime due to maintenance in place feature. And last but not least, package unit, so very easy to integrate into your SCADA system. Integrated pipe cleaning by air with no additional cost. That is the way the smart air injection technology works. And that means that we can fully clean the pipe and therefore avoid any issues with cloggings, whether the tailings dried or froze in the discharge pipe. And a low footprint for the pump. Just a little recap here. We've seen these are all the patented maintenance featured by SEEPEX. So MIP pumps, maintenance in place, no need to take the pump to the workshop, no need to disconnect suction or discharge. You see here all the different features we have to make sure we have independent access to the wearing part, whether rotor or stator, whether the sealing with SSH, smart seal housing. We've seen rotor joint access, drive joint access with sliding compression casing. Again, making sure we simplify the maintenance. And SCT auto adjust, that is taking SCT to the next step. That means that you can observe the flow rate decreasing from your control room, and you just push one button that will actually retighten some kinetic ring that are on our stator, and that will retighten the stator automatically without you being physically near the pump. So all these are patented features by SEEPEX, making sure we reduce downtimes, making sure the maintenance is easier and requiring less efforts. So large source of progressive cavity pump, we've seen the standard range, we've seen the T series with the hopper, we've seen we have the MD series for the small flow rate, all with their easy maintenance feature, large choice of material of construction to handle the various chemicals we can find in mining industry, spare parts availability, of course, global presence with over 80 distributors worldwide, making sure you have local contact. And of course, do you have any question? Please do not hesitate. And you have here my email address. You can reach out to me should you have any specific question. Any questions on the presentation?
Yes, so thank you, Magali, for this a nice presentation and for this very good explanation of all our products and the options and applications. Let me have a look firstly. Currently, we don't have any questions so far. So that means your presentation was so good.
Very clear.
Very clear. But yes, but this is my experience. Normally, the questions will arise also afterwards, or maybe after the next day. Yes, we can wait a moment. Some notes from my side. So our participants, they will get the recorded session from automatically, yes, via email. So that means you can have a look once again. And please feel free to contact Magali directly or SEEPEX, and we have a very good reception, so they will forward your questions. Yes. Okay.
And please don't hesitate to reach out to me, whether in French or in Spanish or English. That's okay for me.
Yeah. Okay. Yes, what I can see in that also in our audience, we have some potential customers as well as our distributors. So this is also very good that they also have a look. And now I've got one question. I will read it directly. So we see a lot of peristaltic pumps on mining applications. Where does a SEEPEX have an advantage over this pump type?
Yeah, I would say today, again, the limitation will be for peristaltic, the pressure capabilities. Peristaltic will advertise 15 bars. That is maximum pressure. However, above 4 to 5 bars, the flow rate is not stable at all. So in dosing application, I would say that is a limitation, definitely. We know as well that they are pulsating flow rates. So whenever we have large distance, that means we need to install pulsation dampeners. So that comes at an extra cost. Today, I would say that progressive cavity pumps, especially with all the design feature we have on the T series, we are able to transfer very thick slurries with high density, close to above 3. So today, I would say that we have higher flow rate and higher pressure capabilities. Makes the difference, and that's why it opens wider application for PCPs. The peristaltic indeed are used, especially when we have some chemicals. However, disadvantage is the mining industry works 24/7, so the wearing of hoses can be quite frequent due only to the rollers and that will wear out the hoses, probably more sometimes than the fluid itself, but just the functioning principle will wear out the hose very fast.
Okay. Yeah, thank you, Magali. Okay, but this was the only question so far. So, but I think we can close our webinar for today then.
Okay, and please, you got my email address, so don't hesitate should there be more question.
Yeah, okay. So we hope we see us again during one of our next webinars or live. So have a nice day, have a nice evening wherever you are. Yes, and I would like to say goodbye.
Thank you very much, everyone. Have a great day further.